Hello guys, welcome to Precalculus. This is Mike coming at you with our first video. In this video we are going to do a little bit of a review. These functions are hopefully things you have seen before in previous math courses that you have taken, but we are going to talk about quadratic functions and their properties. First of all, just a quick recap of what is a quadratic function. A quadratic function is any function of the form ax squared plus bx plus c, where a, b, and c are all real numbers, and a is not equal to 0. We need a non-zero number in front of that x squared in order to make it a quadratic. And if we graph a quadratic function, the shape we get is a parabola. Looks either something like that, or it can look something like that. But now the question is, when does it look like which? When is it going up on both sides, or when is it going down on both sides? So this is where we get into the properties of the quadratic function. As we just said, they may open upward, going up on both sides, or they may open downward, going down on both sides. And what really determines whether it opens upward or downward is really what the value of a is. If a is positive, then the parabola is going to open upward. If a is negative, then your parabola is going to open downward. So if you have a positive number in front of your x squared, then that thing will go up to the left and right. If the number in front of your x squared term is negative, then it's going to go down to the left and right. And there is a general set of rules that we follow for when we get to other functions with higher powers of x, I'll say for now, that based on what that number is doing, as well as based on what your power is, that's going to tell us what's happening at both ends of the function, if you'll call it that. But we'll get into that in the next video. All parabolas have a line that goes vertical, over which they can be quote-unquote folded in half. This is called the axis of symmetry, or AOS for short. I'm sure that's a phrase that you all have heard of in your previous math classes, wherever you took them. And then all parabolas also have a turning point called the vertex. If that a term is positive, that a number, then the vertex is going to be the lowest point on the graph of your parabola. If a is negative, then the vertex is going to be the highest point on that graph. So there are two common forms that we put a quadratic function into. The first one is actually the less common of the two forms that we typically say these things in, and this is called standard form. We can write any quadratic function in the form a times the quantity x minus h squared plus k, where h comma k is the vertex and x equals h is the axis of symmetry, or as I just mentioned, AOS. Now there's a couple things that I want to point out here that you have to be very careful that you look for when you are recognizing the vertex and the axis of symmetry for a quadratic function in standard form. If you look at the x minus h piece here, note that it's a minus sign there in the middle of the x and the h. So if you're seeing x minus blank, x minus, say, 3, then that means that your h value is going to be a positive 3. So seeing x minus something means that that something you have there, which is your h value, is going to be positive. And then note here it's plus k. So if you're seeing minus something, like say minus 4, that means your k value is going to be negative. It's going to be minus 4. So just a couple things, a couple signs that you have to be very careful with when you try to identify the vertex and the axis of symmetry for a quadratic function in this form. So just as a couple quick examples, what is the vertex and the axis of symmetry for this quadratic function? 3 times the quantity x minus 1 squared plus 4. All right, well, comparing this to our standard form here, I see x minus h, x minus 1. We just said that if there's a minus sign in here, if you see a minus here, then your h value is going to be positive. So our vertex, the x-coordinate, which is the h, is going to be a positive 1. And then k, here it's plus k, here it's plus 4. That means our k value is going to be positive as well. So that's going to be a 4 there. And then when you know the vertex, you thus know the axis of symmetry, because the axis of symmetry is just x equals whatever your x-coordinate is here. So it's going to be x equals 1. So that's our vertex and our axis of symmetry for this one here. How about f of x equals x plus 6 quantity squared minus 1? Okay, well now we're seeing a plus here, not a minus, which means that if you see a plus in here, that means your h value is going to be negative. So it's not going to be a positive 6, but it's going to be a negative 6. And then our k value, in the standard form it's plus k. Here we have a minus 1, so this tells us that our k value is going to be negative as well. And it's going to be a negative 1. That's our vertex. The axis of symmetry is just x equals the x-coordinate of our point here. X equals negative 6. So those are just a couple samples with finding the vertex and axis of symmetry of quadratic functions in standard form. Then we have the more common form that we typically see these things in. I'm just going to call this ax squared plus bx plus c form. There really is no other nice name for it. You would think they could have come up with one, but mathematicians are lazy. So how do we figure out the vertex and axis of symmetry? Well, the x-coordinate of your vertex, and thus the one piece of information needed for the axis of symmetry, is that x is going to be negative b over 2a. Whatever that is the x-coordinate of your vertex, and that's also your axis of symmetry. To find the y-coordinate of your vertex, simply take that x value and substitute it back into your function. So that's why I say it's minus b over 2a, comma, f of minus b over 2a. So what's the vertex and the axis of symmetry for this guy here? Negative 3x squared plus 6x minus 7. So the one place where people can get really tripped up here is not correctly identifying your a, b, and c values. Looking back at the top here, this is ax squared plus bx plus c. So if you see any minus signs in front of any of your numbers here, it means that those values are going to be negative. So we're going to have our a value of minus 3, our b value of positive 6, and our c value of negative 7. So if we do negative b, that's going to be a minus 6 divided by 2 times my a value. 2 times negative 3 is negative 6, and negative 6 divided by negative 6 is a positive 1. So that's the x-coordinate of my point, of my vertex. To find the y-coordinate, just take that x value and substitute it back into the given function. 1 squared obviously is 1 times a negative 3 is negative 3. 6 times 1 is 6. So we have negative 3 plus 6, which is positive 3. And then 3 minus 7 is negative 4. So there is our vertex. And then the axis of symmetry is just x equals the x-coordinate of our vertex. Second one here, some larger numbers getting involved here, seemingly a little bit more complicated. Try this guy on your own. See if you can figure out what the vertex and axis of symmetry for this quadratic function is going to be. So press pause, and when you think you have it, press play, and we'll see if you were right. All right, let's see if you were correct. We need the x-coordinate, negative b over 2a. It's going to be minus the negative 44, pardon me, so plus 44, all over 2 times my a value of positive 11, 22, and 44 over 22 is 2. If I take this x value of 2, plug it into my function f of x. 2 squared is 4 times 11 is 44. 44 times 2 is 88. So I have 44 minus 88, which is negative 44, plus 1, which is negative 43. And then since we found the x-coordinate, that is our axis of symmetry. X is equal to positive 2. So that should be a little bit of a recap. It really shouldn't be anything completely brand new, completely out of the usual. We can convert between the two forms, one conversion being significantly nicer than the other. If you're going to switch from standard form to the common form, so from that a times x minus h quantity squared plus k to the ax squared plus bx plus c, you simply FOIL things out, you multiply numbers in, and then you combine like terms. So if I wanted to take 2 times the quantity x plus 3 squared minus 7, if I wanted to convert that into our common form, I'm just going to FOIL the x plus 3 times the x plus 3. That gets me x squared plus 6x plus 9. I'm going to then multiply the 2 into each of those 3 terms to get me the 2x squared plus 12x plus 18, and then I still have that minus 7. And then I'm going to combine the two constants. 18 minus 7 is a positive 11. This conversion, this switch is the nastier one. This one requires a little bit more work. So to switch from that ax squared plus bx plus c form to the standard form is going to require us to do something called completing the square. So suppose we're given x squared minus 8x plus 1, and I want to convert this into our standard form. Completing the square, you are going to look at the x squared term and the term containing an x. Here, in this case, it's x squared minus 8x. What you're going to do, as a recap for those of us who may not recall how to complete the square, is I'm going to take my b value, which is that minus 8 here, and I'm going to chop that guy in half. So I have negative 8 divided by 2, which gives me negative 4. I'm then going to take that guy and square it. So negative 4 squared gives me a positive 16. Now, I want to change how the thing that I'm given, the x squared minus 8x plus 1, I want to change how that looks so that it includes a plus 16, but I don't want to change the fundamental quantity that I have. So how can I rewrite this plus 1 here involving a plus 16? Well, if I write 1 as plus 16 minus 15, then that gives me the same quantity, a positive 1, but it gets that plus 16 in there like I am searching for. So that's exactly what we're going to do. We are going to write this as x squared minus 8x plus 16 minus 15. I'm now going to look at the first three terms here, the x squared minus 8x plus 16. Remember when we took our b value and we chopped it in half and we got some number here? In this case, a minus 4. Well, when you write what you have as the perfect square of something, that something being squared is going to be x, and then whatever this number is right here, including the sign as well. So x squared minus 8x plus 16 is equal to the quantity x minus 4 squared. And the way that you can verify this, if you want, is to actually FOIL out x minus 4 times x minus 4, and then subtract 15, and you would get back to x squared minus 8x plus 1. But it all goes back to that completing the square. That is a little bit tricky. It can be a little bit challenging. Try this guy on your own. This one is going to be a little bit more challenging, but you do come out with an answer that is not too bad. Try to complete the square for this guy right here. X squared plus 7x plus 1/4. Once again, you only want to look at the x squared and the x terms. You're going to work with that number that's in front of the x. You're going to work with that b value and think about what we did. We took that number, we chopped it in half. That number that we came up with there, we squared that, and we want to rewrite the constant so that it includes that square that we found, but we don't want to change the fundamental quantity that we have. So pause the video here, try to figure it out on your own, and once you think you have it, press play and let's see if you are correct. All right, so let's see if you came up with the correct answer. So I'm going to take that number 7, chop it in half. That's going to give me 7 halves. Note this value for the end. I'm going to square this guy, and this gives me 49/4. Now, I want to rewrite this 1/4 to be this plus 49/4 minus something. So what number do I have to subtract from 49/4 to get 1/4? Well, if I subtract 48/4 from 49/4, then I get 1/4. But 48/4 is also 12. So I'm going to add the 49/4 and subtract the 12 at the same time. The sort of intermediate step here, which I'll write out, is x squared plus 7x plus 49/4 minus 12. And then we saw that value that we got after chopping this guy in half, that 7 halves, we take that number as well as the sign that goes with it, and we stick it at the end of x. and that is why we have the 7, or the x plus 7 halves. Pardon me here. So it's x plus 7 halves squared minus 12. So that one was a little bit nastier. You got fractions happening inside of there. For the most part, not the typical kind of problem you would see from me, or just that you would see in general, but just know that it is out there. These quadratic functions actually do have some real-life uses. There are many real-life applications that involve quadratic functions, mainly in maximizing or minimizing a particular quantity. How would you solve such a problem? Well, here's sort of a list of steps that you can use to solve such a problem. First thing is you want to determine the quantity that's going to be minimized or maximized. It could be, say, the area of a plot of land, or it could be you want to, say, maximize the profit that your company is going to make on something, or you could want to, say, minimize the cost of something. And then you would write the formula for that quantity as a quadratic. Now, at this stage of the game, considering this is just pre-calculus, things may be given to you already in just one variable, but perhaps it wouldn't be too much of a challenge to give you things in two unknowns, say x and y, and then you can get y in terms of x and make a substitution in. If you're going to move on to pretty much any Calculus 1 course, you'll see that is how you would solve these types of problems. There is a special name for these kind of problems as well. They're called optimization problems. But you'll encounter those much more in Calc 1, not so much here. Then step 3, you're going to find x equals negative b over 2a. So this is assuming you already have it in that nice ax squared plus bx plus c form. If a is positive, then the x value that you find is going to minimize that quantity. If a is negative, then the x value will maximize that quantity. It's going to minimize it because if a is positive, then your parabola opens upwards, and that x value is at the bottom of it. If a is negative, the parabola opens downwards, so that x value is going to be at the top. And then step 4, you have to answer the question. The question may not say what is the x value that maximizes the profit. The question may say what is the maximum profit. So you just have to substitute that x value back into your function and then answer your problem. So this is a sample here of a type of problem that you could perhaps see. A company calculates that their profit on selling X units of their product is modeled by the quadratic function negative 3x squared plus 600x minus 1,000. What is the maximum profit they will make? Now, the question tells us or asks us what is the maximum profit, so we know what we want to maximize. And the function is already given to us in a nice quadratic form in only one variable. So we just need to find that x value, that negative b over 2a. And since the coefficient of that x squared, that number in front of the x squared, is negative, this is indeed going to give us the maximum value. It is going to maximize our profit. So that x value where the maximum happens is negative b minus the 600 divided by 2 times that negative 3, 2 times a. So I have negative 600 divided by negative 6, and that gives me a positive 100. Now the question asks what is the maximum profit? So we're not quite done yet. We just have to take our x value of 100, plug it into our function, and see what we come up with. and you come up with, in the end, $29,000. So we know that the maximum profit that this company will make is going to be $29,000, and we know that they'll get that maximum profit when they make and sell 100 units of whatever product they make. So this is just, or this was just, a little bit of a recap of quadratic functions, basic forms, converting between those two forms, what do their graphs look like overall, and some properties of those graphs. In the next video, we are going to talk about polynomials of higher powers and some properties of these guys, as well as some features of their graphs, including end behavior. If you have any questions or comments, be sure to reach out to me. Send me an email, send me a letter through the mail, any way you need to do, or anything you need to do to get a hold of me. But otherwise, until the next video, take it easy, guys.